Let's jump right in. Welcome to the Explainer. Now we address one of the most common runtime issues in Java, null values and the notorious null point exception. If you've been writing Java for a while, you know this error is like a clingy friend, right? It just shows up when you least expect it, wrecking everything. But good news, by the time we wrap up today, you're going to have the ultimate tool to trap it and keep your code running beautifully.
Here's our quick roadmap for today. We'll start with the null pointer problem, introduce Java optional, cover core methods and approaches, look at some key rules and insights, check out common use cases, and finish up with a challenge and recap. Let's get to it.
All right, section 1, the null pointer problem. For a really long time, standard Java let us leave variables pointing to absolutely nothing, which honestly is a recipe for catastrophic crashes. Take a look here. We've got a string explicitly set to null, and right below it, we try to print its length. Well, guess what? This causes a runtime error because the value is null. There's literally no length to calculate. Bam! The program crashes with a null pointer exception. It's unsafe direct access at its absolute worst.
So that brings us to a massive question. How do we safely handle missing values without constant null checks? You know what I mean. Those messy, defensive, nested blocks that completely clutter up your logic. There's got to be a cleaner way, right?
Which brings us to section 2, introducing Java optional. The optional class is used to represent a value that may or may not be present. Think of it like a little container box. If there's something inside, awesome. If the box is empty, it safely represents that absence without actually being null itself. Basically, it helps avoid direct null checks and reduces runtime errors.
Let's see this in action. We import optional from java.util. Then, we create an optional string called name, and we initialize it with optional.ofNullable, passing in null. This wraps the value safely. Because we pass null, our little box just registers as empty. No exceptions, no crashes, just perfectly safe code.
Moving on to section 3, core methods and approaches.
The most basic way to check our new container is with an if statement using the isPresent method. If the box isn't empty, it returns true, and we can safely use the get method to pull our value out. This avoids direct null access. But wait a second, doesn't this look suspiciously like those old messy null checks we were just trying to get rid of? Yeah, we can definitely do better.
Enter the recommended, much cleaner approach, simply calling orElse and passing it a default string. If the value is present inside our optional, it prints it. If value is absent, a default is returned automatically. One line of code, super readable, zero null pointer exceptions. It is a total game changer.
Okay, let's rapid fire through the key methods you need to know. First is isPresent, which checks value presence. Then we've got get, which retrieves the value. But listen, if you call get on an empty optional, it'll throw an exception, so watch out. Next is orElse, giving you a default value. And lastly, orElseGet, which gives you a lazy default. This one's super cool because it only computes that default if the optional is actually empty, which saves you some processing power.
Section 4, key rules and insights. Now that we've got these shiny new tools, we absolutely must lay down the ground rules to prevent a total disaster. The absolute golden rule? A variable of type optional must never, ever be null. Never, never, never. If you assign null directly to an optional variable, you are literally defeating its entire purpose. Use optional.empty instead, period.
Next rule, avoid excessive use of get without checking presence. And honestly, try to avoid the whole isPresent paired with get combo altogether. It's kind of considered an anti-pattern now. Instead, you really want to lean into those clean, functional methods like orElse or orElseGet. It makes your code look so much more professional.
If there's one big takeaway here, it's this. Optional shifts null handling from unsafe direct access to controlled value handling. We are entirely taking the guesswork out of missing data. Instead of crossing our fingers, we're interacting with a solid structure that forces us to deal with both the presence and the absence of data right up front.
All right, section 5, common optional use cases.
So where do we actually use this? The biggest best practice is to use optional instead of null on public return types. This is exactly what the JDK architects designed it for. Let's say your API can't find a user in the database. Return an optional user. The person calling your API instantly knows the value might be missing, and they're forced to handle it safely.
To sum up the best application spots,
Use them for API return values, use them for configuration handling when settings might just be missing, and use them for avoiding those deeply nested defensive null checks. It just brilliantly cleans up your overall architecture.
Just look at this transformation. The old way of extracting a nested property meant layering if check after if check. Messy, right? But the new way? Because optional supports stream-like methods, you can cleanly chain .map and .filter. You map from a user to an address to a zip code in one smooth, highly readable Fluent chain. If any piece is missing, it just quietly falls through to an empty optional. It's beautiful.
Wrapping things up, Section 6, Challenge and Recap.
Time for a quick micro challenge. Pause and try this. Create an optional with a null value and safely print a default. Do it in your head or fire up your IDE real quick. Give it a shot.
Okay, here is the solution. We initialize it with optional.ofNullable passing in null. That safely wraps the null into an empty container. Then we just use the functional approach. System out println, calling test.orElse with our default string. Because it's empty, it seamlessly skips to the default and prints success. Nailed it? Awesome.
To bring this all together, remember this core insight. Optional provides a structured way to handle missing values and prevent null pointer exception. It isn't just syntax sugar, guys. It's a fundamental shift in writing robust, readable code that actually sleeps soundly at night without fearing unexpected crashes.
So, are you ready to integrate optional into your code? Go look at your old APIs and see where you can swap those messy null returns for a clean optional wrapper. In the final explainer, we'll build a project that integrates the concepts you've learned throughout this course. Stay curious, keep coding safely, and we'll see you in the next one.